Welcome to my channel again. Today I'm going to do something short and simple for you about Gretl. We are going to use time series data, which I've already loaded into Gretl. Today I'll be showing you dynamic estimation, which I believe you know already. Dynamic is all about having the dependent variable as um, having the lag of the dependent variable as part of the equation that you are estimating. So what I'm going to do now is that first, you can choose to transform the variables into logs, but we can also try to estimate it because I've not converted the variables into log. So this is the variables. These are the variables I'm using. This is GDP, export, and import. I've not converted them into logs, but let's try to estimate it in the first place. So we go to model, ordinary least squares, click on it, select the dependent variable, select export, import. These are the independent variable or regresses. So because we want to estimate a dynamic model, we need to click on lags. So here we don't need lags of the independent variables. We only need lag of the dependent variable. So here we click on this one, which is the lags of dependent variable. So take this one. Now the option has pop up, so you'll be able to select the number of lags you need. So for instance, I need only one lag. So this is okay for me from lag 1 to lag 1. So I'll just click on OK. So now you can see the lag of the dependent variable has been added to the regresses. So just click on OK. Now you can see here, most of the variables are not significant, but the lag of the dependent variable is significant. So it is also giving you a lot of information here, excluding the constant p-value was higher than, as this is what it's talking about here. So here we can also do the normal test, because once you run a dynamic model, it's the Debye-Waxen value is not, normal Debye-Waxen is not capable of testing for autocorrelation. So here we need to run the highest level of autocorrelation. So here we can try from this side. We can choose up to like 4 or like 5. Click on OK. So we can see here that there is no autocorrelation because the p-value is 0.06, and the rest here are just normal things that you can also talk about, the alternative statistics and then the other part of it. So once you test for autocorrelation, it will appear in the model, it will appear on the model that you've estimated. So the next item you can also test for, or you can also test for maybe autoregressive conditional heteroscedasticity. Click on this. You can also increase it to maybe like 5. And then click on this one, which is giving us a p-value of 0.83, which means that there is no autoregressive conditional heteroscedasticity. So close this one. You can test for normality, you can test for heteroscedasticity, as maybe we can use Brecht-Pagan. So you can see there is a problem of heteroscedasticity here, which I believe can be a problem of maybe lack of incorrect specification of the model. So you can also use this one, Ramsey reset test, to check if whether the model was correctly specified. And you can see that here, using reset specification, squares and cube, we had, which means that the model is correctly specified here. Here too, we can run this off to show that the model is correctly specified, because if you run this one, it's gonna give you 0.05, and here you can see there's a problem of model specification. So always try to get the right model specification, because this is just a tutorial video just to explain this one to you, and make sure that you do the right thing, because I've already explained why these things comes up in the model when you have an incorrectly specified model. So you can watch my other videos to find out more about it. So now we are done with this one, the which is the model estimation for dynamic model. So let me try and do something about distributed lags, which we have the lags of the independent variable also part of the model. We will not include lag of GDP because we want to estimate the distributed lag model. So just let's try this one and see. I'll close this one. Let me just close this one. So, or we can also edit the model that we've estimated. So I can just model specification, modify model. So here, I'll just kick this one out, go to lags, and here I don't need lag of the dependent variable. I only need for the independent variable. So let me just do this one. You can use this one as default. Here I can choose one. As you see, if I use the default, it's going for all the independent variables. I want lag 1 to lag 2, or we can also increase it to lag 3. We are just trying here. So okay, so you can see they have all appeared here. You just need to click on OK. So as you can see here, when I click on OK, you can see that we have a Debian-Watson value, which is within the acceptable range, which is 1.5 and up to 2.5. So you can see here that most of the coefficients are not significant, but this is just a tutorial video to explain how you can estimate the distributed lag. And also you can also do your normal test here using this one, and you can see that there is no heteroscedasticity. Also you can check for normality. You can see it's normally, the error terms are normally distributed. So you can close this one. You can also check also for autocorrelation, which we can also check for the highest order up to like 5 and see. You can see there is no autocorrelation here because the p-values are greater than 5%. And I can close this one. Also you can do this one, autoregressive conditional heteroscedasticity. I'll choose this one, and you can see we don't have any problem of autoregressive conditional heteroscedasticity here. So we can check for Ramsey reset or variant. You can see it shows that the model is correctly specified. These are the p-values here, and I believe that is all for this video, and just stay tuned and wait for my other videos coming up. Thank you very much.